First problem from today's weekly contest, count partitions with even sum difference. We're given an array nums of length n and we need to basically find the number of left and right subarrays that we can find such that the sum of the left subarray and the right subarray has a difference, absolute difference to be even. We want to find all such partitions. So what we can do, this needs to be non-empty by the way, both the partition. So we start from here and we go till here such that this will be the left as the maximum subarray and this will be the right as the maximum subarray because it needs to be non-empty. And we can have the total initially, and as we start we will lose from the total, so that will be the right subarray sum, and we can have a running sum for the left subarray. All right, so for that we need n. Let's get the n nums of size. Let's have answer initially with 0. Let's get the total, or let me call this right instead. I'll use the accumulate function. We can iterate as well. Right, initially the value will be 0. The running sum will be inside the left variable initialized with 0. And I can start. I will go till n minus 1 so that the right sub array always has one element at least. All right, so let me do that. And first, instead of calculating, I will update the left and right so that the left also has initially at least one element before the calculation. So left plus equal to nums of I. Similarly, the right will lose nums of I if the difference between the two, left and right, comes out to be even. In that case, I will increase the answer and let's return the answer here. Let's see if this works. Constant space, linear time. Let's see. All right, let's move to the second question. Count mentions per user. So we're given number of users as an integer. Total number of users is what number of users means. And an array which has every event has three things. All right. The first, and these three things can be of two types. All right. Either it can be a message or it can be an offline message. Right. Every message or every event has the timestamp and a mention string. Mention string can be of few types. We can have numbers such as ID1, ID2. It's not mentioned here, but in the example, let me show. It can be something like this. This is a mention string, ID1, ID0 with a white space in between. All right. It can be just one, it can be empty. Is it? Probably it can be empty as well. I'm not sure, but we don't have to worry about it. It's not going to change anything. And lastly, we have offline. Also, apart from this, we have different kinds of string. We can have all, we can have here. All means all users. That means all the users that we are given. Here means only online users. So initially when the users come, before the first event comes, we have all the users as online by default. All right. So we need to use or keep a state of all the elements or all the users being online or offline, we'll be defaulting that value to be online initially. So we have another event offline, which also has a timestamp and a ID. This means that this particular user is going to be or going to go offline. It's going offline from this timestamp for 60 more seconds or 60 more time units, and we'll get off online back again after this timestamp. All right. So we can have something of a we can have multiple users, by the way, offline at the same time. So we need to keep count of who is the most who is the user with the lowest timestamp to go online, right? A priority queue makes sense here. You can have a min heap to have all the offline users with the timestamp of when they will go online as the first element. The second element being the ID, because we'll be going to need that, because when they come online, I will need who came online so that I can update a status, which can be a map of all the users initially with offline online, and when they go offline and come back online, I can update that accordingly when they go to the respective state. And then we have to return an array mentions, which will include the number of mentions that that particular user got across all the message events. And that's it. The most important or one of the important thing is a user can be mentioned multiple times in a single message event, and each mention can be not this one. Uh, yeah, this one. All users are initially online. If a user goes offline or online, the status is changed. It's processed before handling any message event that occurs at the same timestamp. All right. So any message event should come if both message event and offline event have the same timestamp. In that case, message event should be processed later on. Offline events should be processed before. All right, that's what they mean. All right, so we can solve this problem by having few things. Firstly, we need to arrange this events in order. What is that order? That order should be based on timestamp. The earlier events or the events that will occur before any other event should be first. If they have equal timestamp, then in that case, all the offline events should be first, and then the message event should be there. So we need to sort. So events.begin, events.end. I can have LHS, RHS. We need to sort it based on timestamp, which is a string. So I need to convert it to integer first. Let me call this LT and RT. This will be LHS 1 because first element is the timestamp. This is going to be RHS and RT. If they are equal, in that case I need to write. If they are equal, if the timestamp is equal, in that case we need to do the sorting based on if it is a message or offline. Message and offline, basically if they are compared, offline will always be MNO, offline will always be larger, right? So in that case I want this, so I want to do it in descending order based on the first element. So LHS of 0 greater than RHS of 0. Otherwise, LT less than RT. So the sorting is done. We need to maintain status and priority queue. So let's have a vector of n. The values of the number of users will be basically IDs from 0 to number of users minus 1. So we can have a indexing based on number of users. And that will be the size. Initially, one can be online status. Priority queue will be min heap, so it will hold two values, timestamp and ID. So I will have a vector of int. This will be the min heap. I will now start processing the events, or you know what, let's get the event for from events. First, let's get the timestamp. We will be needing timestamp for either of the events. So timestamp, that will be a string. So I need to use the stoi function in C++. We can do it other ways as well. That will be the first element in the among the three elements that we have inside event. Now let's start. Before doing anything, before even processing anything, we need to do a pop from the priority queue, because we need to process before we need to process the part of user coming offline or going offline, coming online or going offline before handling any event, right? So in that case, we can do the processing right here, and that processing will depend if min heap has element or not. So min heap should not be empty, and the top of the min heap is having a value that is smaller than equal to the timestamp of this event. If that is the case, then this user should come online. So I need to pop the user from the priority queue, but before popping, let's update the status. It should be offline for this user. We need to convert them to online. What is the timestamp, or what is the ID? That is the first element, and that will be changed to 1. And that's it. At this point, I'll check what kind of event it is. Event of 0. By the way, I'm doing something wrong here. This should be event of 1, not events of I. Anyways, if events of I of 0 or event of 0, if it's equal to offline, in that case, I get the ID using the stoi function. That will be just the ID for the third element. That will be event of 2. I will push that inside min heap along with the timestamp when that user will come back online. So timestamp plus 60 units and the ID. uh, the status will be changed to 0 because they went offline, and that's it. Else, if it's a message, in that case, I'll get the mentions first. Based on that, things will happen. So, event of 2 is the mentions. Now, if mentions is equal to all, in that case, I will just traverse through all the users, that is from 0 till number of users, and do a increment inside answer. Let's have an answer here. That will be the count of the number of mentions for every individual number of users. So this will be the size. Initially value will be 0, and I will do a increment for every I by 1. Else, if mentions, or if it's equal to here, that means only users which are online. So let me copy this and increment answer of I only if status of I is 1. Else, we have few users, or we have the mentions in this format: ID1 space ID0, and so on and so forth. And this can be ID12, ID300, and whatnot. All right, so we need to start from the second position and keep continuing till we find a white space, get that string, convert it to integer, and use that ID to do whatever, increment dimensions. And then we need to do that same thing until we exhaust all the IDs inside the mentioned string. All right, so I will start looping from the second position, uh, continue till I have mentions length exhausted, and I will not increment by 1. I will increment something more by 1, something more than 1. What will be that? Well, if I have something like this, I am here, or let me take another example. ID 12, 123, ID 12, ID 1. All right, I am here, or I, and I continue, get the string till I find a space. All right, I'm at this point. I'm at a space. So space, from space, I need to jump once, go to I, jump another, go to D, and then jump the third time. So every time I'm at a space, I need to jump 3 times. So I'll do a I plus equal to 3. All right, get the string. Initially, let me keep it empty, and then while uh, I'll do another while loop. While J is I is less than mentions dot length, keep going, and mentions of I is not equal to space, white space. In that case, get the character inside string ID, do an increment of I. At this point, get the ID, Okay, strid and increment, whether it's offline or online doesn't matter, whether it's duplicate or not, it doesn't matter. I need to count it separately. So I will do a answer plus plus. That's pretty much it. All right, let's return answer. Let's see if this works. Okay, min heap.empty. Okay, something is still wrong. Should be 0. Let's see now. It does work. This is a sorting base. So O of n log n, time complexity, space complexity will be O of n. We have a heap here. So let's move to the third question of the contest. Maximum frequency after subarray operation. We are given a nums of length n, integer k, and we need to select a subarray, any subarray, and in that subarray add a integer x, integer, so it can be positive, negative, to all the elements in that subarray, and we need to find the maximum frequency of the value k after the operation. So we have a k, we need to choose the operations or choose a subarray and choose the integer what we need to subtract or add in order to maximize the frequency of k. So firstly, there can be two scenarios. Two, to be specific, some elements might already be k, some elements need to be converted to k. If I choose one of them, I cannot satisfy the other, right? It's not like I can add or subtract 0. That does not fulfill anything, right? So if I choose this, I am not choosing this, right? But if I choose this, I am losing this. What did I mean by losing this? So if I have a key, or if I have a subarray, something like 5, 3, 6, 5, 5, all right, and I have a key to be 3. In that case, if I choose 5 as the element to convert to k, then I cannot choose any other element in this subarray to be converted to k, because any other element apart from 5, if I add or subtract an integer greater than or less than 0, in that case I will end up changing this 3 to some other value, right? Since I will be doing a minus 2, a minus 2, a minus 2, and a minus 2, I'll end up getting this. So I lose this k, but I will gain 3 k's. So this will be the answer. So 3 will be the answer, by the way. So we need to return the number or the maximum frequency we can achieve. But if I have something like this, some more 3's here, suppose I have 3 here. In that case, if I choose this subarray, then this can also contribute to the frequency of k. In that case, my answer will be 4. All right. So this can be converted to a cadence algorithm. How can we do that? We can, what does cadence algorithm state, by the way? It is nothing but it's a standard problem of finding maximum sub-array sum, non-empty sub-array sum. So if we have a length n integer, we have some array. We can have negative or positive. Suppose we have something like uh, something like this. So here, if I start, if I try to solve this problem in a greedy way, I start here. I choose my answer to be 4. Then should I choose -1 or should I not? But I'll be greedy and I will try to choose -1 because it's still greater than 0. And later on, I might get some value that is bigger because it needs to be continuous. That's what subarray means, right? If I lose this, then I lose the streak of being continuous and I lose the 4 as well. So I don't want to lose the 4 and that's why I take -1, make it 3, move forward. See, I have a 2. I take, uh, you know what, let me take this, make this -5. Let me make this, let me remove this. That will help. So I take 3, sorry, I take -1, make it 3. I take 2 more, make it 5. Now it's equivalent of saying that I have 5 here and this is the problem right here. I take -7. Alright, I make it -2 by taking -7. But should I have taken -7? No, I should not have because why will I take any element which is making my overall sum negative instead of not taking that element and moving forward, right? So I cannot take, suppose I break this subarray now, I lose everything, I make this 0. This is better than having -2. And that's what cadence algorithm is in brief. So we are going to use that here. How are we going to use that here? Here we have 50 elements in the problem. So I can strictly make one element, choose and choose that one element, try to convert it to k, or among these 50 elements I will choose every element and assume that this is the number that I am going to convert to k. Right, that's a better explanation. So among those elements, how will I try to convert it to k? I'll try to start iterating. If that element is not equal to the element that I have chosen, I will do nothing. If that element is equal to k, in that case, I will consider that -1 because I'll be losing uh, a k that would have contributed. So what I'm saying is I will choose a element from 0 to 50 as the element to be, sorry, to be converted to k if chosen element, let me call it I, if I is equal to k, lose element, hence consider it as -1 if I is equal to I mean the number, or let me call it nums of I, gain a element because I am gaining an element because it's going to contribute to the frequency of k, hence consider it as 1, else just do nothing, move forward. Alright, and I can keep track of the maximum sum that I am able to achieve. I'll do that. I'll have a global index for every element to get the maximum, and that global index or global maximum will be my answer. So for that, I am going to need total k, because there will be scenarios where I have a subarray, I have boundary elements, right? I have few keys here, I have few keys inside, and I have few keys here as well. In that case, if I consider this as a subarray, in that case, this and this k should also have contributed, right? And that's why I'm going to get a total k using the count function. I can use that, or otherwise I could have iterated what I need to count. K is what I need to count. Let me call extra k as initialized as 0, because this will be the subarray that is going to give us some extra k, right? Because I'm going to choose some element that is going to be converted to k, and that will be the extra key that is going to contribute. So out of these 0 to 51 elements, let's fix one element, that is I, to be converted to k. So if it is already equal to k, then do nothing. By that I mean if the element is already k, so don't fix k to be k, right? Because it's already k. So in that case, continue. Otherwise, let's find the contribution of k, or the frequency of k, if I is considered to be converted to k, right? So in that case, iterate through nums again. This time check if nums of j is equal to I. In that case, do an increment because I'm converting this particular element to k. So it's going to contribute to the frequency. Else, if nums of j is equal to k already, in that case decrement the count. But if the count, we are following Cadence algorithm, so if the count has become 0, in that case make count a negative. In that case, make count to 0, and let's have a subglobal max, not even global. Let me call this I to k count. Alright, This I to k count will be maximized. So let me declare it among itself and the count that I have achieved in this streak, right? So at this point, I will have a global extra k. Now this will be maximized against I to k count extra k, and I'm going to return this extra k plus the total k that I have. So total k plus extra k, and that's pretty much it. Let's see. Okay, extra k is a problem. Oh, my bad. This should be total k, not extra k. Okay, let me declare count here. All right. So this will be not constant, but 50 into O of n, right? So around O of n, and space will be constant. All right, that's the third problem. Thanks.